All right, today we're diving straight into a cosmic detective story. Our main suspect is a galaxy that, on the surface, looks completely calm, but it's hiding a massive, powerful secret. We're going to peel back the visible layers of NGC 3556, better known as the Surfboard galaxy, to uncover the incredible invisible forces that are shaping it from the inside out. So here it is, floating about 46 million light-years away. From our perspective, seen edge-on, it just looks like this quiet, serene island of stars, right? But that peaceful vibe? Well, it's totally deceiving. This galaxy is actually the scene of a huge, violent interaction, a battle between the gravity holding it together and some other powerful force that's trying to blow it all apart. And the thing is, to see what's really happening, starlight won't help us at all.
So what's really going on in there? What invisible energies are churning away under that calm facade? Well, it turns out the clues are written in a language we can't see with our eyes. They're written in the language of electricity and magnetism, operating on a truly galactic scale.
To kick off our investigation, we need to look at the Surfboard galaxy with completely different eyes. I'm talking about the giant eyes of radio telescopes. We're basically tuning out all that pretty starlight and tuning in to this faint, almost ghostly glow that tells a totally different and much more dramatic story.
So astronomers use these incredible instruments, like the Very Large Array, the VLA, and LOFAR to build a brand new picture of this galaxy. And what they saw wasn't the warm glow of stars. No, it was something way more mysterious. The radio light they detected is something called synchrotron radiation. And this right here, this is our first major clue. It's the unique signature that you only get from super high-energy particles, we're talking cosmic rays, as they spiral around invisible lines of magnetic force. So the big takeaway is, this galaxy is absolutely humming with electricity and magnetism.
Now, this is where it gets really interesting. Look at how different the galaxy looks at different radio frequencies. The picture on the right, which is at lower frequencies, shows this much larger, puffier halo. So why? Well, it's because those lower frequencies let us see older cosmic rays, the ones that have traveled way farther from the galaxy's disk. This tells us that something is actively transporting these particles way out into deep space. They're not just drifting away. Okay, so if we know that this radio glow is coming from cosmic rays interacting with magnetic fields, we can actually use that glow as a tool. We can basically reverse engineer the signal to create a map of the very thing we can't see, the galaxy's entire magnetic structure. It's a really clever bit of cosmic detective work. Scientists look at how the radio brightness changes across different frequencies, and from that, they can figure out the energy of the cosmic rays. Then, and this is the genius part, they assume there's a kind of energy balance between those particles and the magnetic field itself. And with that, they can calculate the strength of the magnetic field point by point across the whole galaxy. And boom, this is what they found. Now, this isn't an artist's drawing. This is a map made from real data, showing the magnetic field's strength. Those yellow and red areas show a pretty powerful field, about 10 microgauss, right in the disk. That's pretty normal for a spiral galaxy. But what's not normal is just how far out that field extends, way, way beyond where the stars are. And this image just illustrates the scale of it perfectly. Here you can see the magnetic field vectors laid right on top of the regular optical image. It's like this vast, invisible magnetic ghost is just enveloping the entire galaxy. But how? How does the magnetic field get stretched so far out into the halo? What could possibly do that? This leads us to the next major plot twist in our story. It turns out the cosmic rays and the magnetic fields aren't just sort of slowly leaking out of the galaxy. No, they are being actively, even violently shoved outwards. You see, when the researchers created models to see how these cosmic rays were moving, they found that simple diffusion, just particles randomly wandering away on their own, it just didn't fit the data. Not even close. The only way to make the observations match the model was with something called advection, or, to put it simply, a wind. A massive galactic scale wind. And the models even gave them a speed. We're talking about a wind blasting out from the disk at an initial speed of 123 kilometers per second. That is over 275,000 miles per hour. And that's just the starting speed. It actually gets even faster as it blows further away from the galaxy. So this is the key. This superwind is the transport system. It's the thing that's inflating that enormous radio halo we saw.
It's literally carrying hot gas and cosmic rays, and it's dragging the magnetic field lines right along with it for tens of thousands of light years.
Which, of course, leaves us with one last really important question. A wind that powerful needs a serious engine. So what in the universe could possibly generate that much energy across an entire galaxy? Well, the answer came from a totally different kind of observation. It was a tiny but incredibly bright signal that acted almost like a flare, lighting up the true nature of the engine that's driving this entire colossal process. That signal came from something called a maser. And a maser is, for all intents and purposes, a natural laser in space. But instead of light, it works with microwaves. They only form under very specific conditions, usually in clouds of really dense, warm gas, and when they turn on, they shine like these brilliant cosmic beacons. And in the Surfboard galaxy, astronomers found a very specific kind of water vapor maser. They call it a KiloMASER. Now, it's a lot less powerful than the mega masers you find near supermassive black holes, and that little detail, well, that turns out to be the smoking gun we've been looking for. Masers are just incredible tools for astronomers, for all the reasons you see here. But in our case, it's the type of maser that cracks the whole case wide open. You see, megamasers, the really powerful ones, almost always point to an active galactic nucleus, like a feeding supermassive black hole. But kilomasers, like the one they found here, they are almost always giant signposts for something else entirely, really intense, widespread star formation. And just like that, all the clues just snap into place. The maser points to a frenzy of star formation. The combined energy from countless young, massive stars and all their supernova explosions creates this galactic superwind. That's the 123 kilometer per second wind we measured. And it's this wind that's blowing all that gas and all those cosmic rays out of the disk, creating that vast magnetic ghost we saw with radio telescopes. Case closed. It's a violent disk halo interaction powered entirely by the birth of new stars. So, we've solved the mystery of the Surfboard galaxy's secret storm. But this isn't just a story about one galaxy. This discovery has some really profound implications for how we think all galaxies live and evolve. See, the Surfboard galaxy is a bit of a loner. It's not being messed with by any other nearby galaxies. That makes it a perfect, pristine laboratory for studying how a galaxy evolves all on its own. It shows us that galaxies don't need violent collisions to change. They have their own powerful internal engines that regulate their growth, control star formation, and even seed the cosmos with heavier elements. And this really gets to the heart of the breakthrough. For a long time, we've seen these huge magnetic fields in the halos of galaxies, but how they got there has always been a puzzle. This study gives us a clear, observable mechanism. Winds, powered by stars, physically drag the magnetic fields right out of the galactic disk and inflate them into these enormous structures. We're literally watching a galaxy build its own invisible skeleton. It really makes you wonder, doesn't it? If a galaxy that looks this peaceful can hide such a violent, invisible storm, just imagine what other incredible secrets are out there, hiding in plain sight, just waiting for us to figure out the right way to look.